A volume-volume problem has me begin with volume of given, and we're going to use that molar volume of 22.4 liters to bring it up to the mole. Right here, 1 mole of given set over the molar volume becomes our first parenthesis. We know that 1 mole of sulfur trioxide would be 22.4 liters big. We want to know oxygen. Its coefficient is a 1. A want over given mole ratio, where those moles are being pulled from the balanced equation. If we want oxygen, it goes on the top. We started from sulfur trioxide, it goes on the bottom. We have a 1/2 ratio. To head back out to the world of volume, notice we're right here. We come down and head back out to the liters of want. 22.4 liters of oxygen for every 1 mole of oxygen. Now notice something very unique to a volume. In step 1, I'm dividing by 22.4. In step 3, I'm multiplying by 22.4. Since our conversions are the same, they are going to simply simplify. With a volume, if you look at your pathway, volume is going to have us divide by 22.4 and multiply by 22.4. That's a unique scenario. Let's hit that out. We have 19.8 times, canceled. We're into the step 2. We need times 1/2. That's 9.9 liters. Now again, this is unique to a volume. I'm dividing by a conversion factor that I'm later multiplying by 22.4. Those will simplify. We have one more on our page. Let's take a read together, please. Read it with me. Nitrogen monoxide and oxygen gas combine to form the brown gas nitrogen dioxide. Let's pause there and get those words into a recipe. Nitrogen monoxide, NO, and oxygen gas combine to form nitrogen dioxide, NO2. Here are those prefixes for these molecular compounds. Let's get it to balance. I have 3 O's here, but only 2 on this side. Let's start by doubling. 2 N's, 2 N's, 4 O's, 4 O's. A 2 to 1 to 2 stoichiometric ratio. Now let's continue reading. We have our recipe set. How many molecules of nitrogen dioxide are produced when 3.4 liters of oxygen react with excess amounts of nitrogen monoxide? Given a volume, calculate the number of molecules. Chart your course. Given a volume, we've got to get up to molecules. A volume molecule problem. Step 1, step 2, step 3. The 3 steps to stoichiometry. Let's begin by writing what's given. The 3.4 liters of oxygen gas. Get our 3-step conversions all set. And now we can see the target is molecules of O2. No, it's not. It's NO2. Glad I caught that. Given the oxygen, we want the nitrogen dioxide, the molecules of NO2. I'm going to rewrite that so it's neater. Molecules of NO2. That's our target. Step 1, we're at the volume. Given a volume, I need to bring it to the mole. I'm tripping over the molar volume conversion. Given a liter, use the molar volume of 22.4. We know that 1 mole of oxygen would be 22.4 liters big. We want over given, the heart of our problem. We want to know nitrogen dioxide. Its coefficient is a 2. Starting with moles of oxygen, its coefficient is a 1. The stoichiometric ratio of 2/1. Here we are on our roadmap at moles of what we want. We want to count the number of particles. To go up to the world of molecules, we use Avogadro on our conversion. 6.02 times 10 to the 23rd molecules of NO2 is equivalent to 1 mole of NO2. Let me get that on the screen a little better. Starting with the volume, we divide, ratio, multiply. Please hit it with me to become confident with your calculator. Start with the given amount of 3.4 liters. Divide by the molar volume, 22.4. For the ratio, we have 2/1 times Avogadro's number, 6.02, second function e, to get that times 10 to the button, 23rd power. And I'm finding 1.8, I'll say 1.83 times 10 to the 23rd power. Before you flip your page, I want to see you give yourself an A+ so that I know you listened to the entire page. When I see this A+ on your paper, I know you've gone through the videos. When that's completed, pause here and we'll be turning the page.